Let's start. Proper animal welfare is a growing concern for consumer and industry alike. But achieving good welfare starts with a good definition and measures to quantify the welfare of an animal. Welfare is very multifactorial, and measuring all aspects of it is challenging to do objectively. Stress in chickens is still often measured by behavior observations, which in themselves are subjective. During this research, I used sensors to investigate whether thermographic imaging and sound analysis could be used as an objective parameter for stress. In order to achieve this, I subjected a group of chickens to stress with an umbrella in order to induce a flight response. Measurements with a thermographic camera and microphones were taken before and after stress, and the results between these measurements were compared. Now the question is, what differences did I find? During a stress event, the surface temperature of the face of the chicken decreased significantly. This was most apparent in the comb and the beak of the chicken and is a consequence of a process called stress-induced hyperthermia. During stress, the blood flows to the muscles and the core temperature of the chicken rises. As a result of this, the temperature in peripheral body parts decreases. Still, using thermography in research or production can be difficult. A lot of physiological and environmental factors influence the temperature in birds, such as the ambient temperature, the humidity, as well as behaviors the bird does, like drinking and eating. Further research into thermography should look into a way to develop a framework that includes all of these factors. For the analysis of the bird calls, I used an algorithm to count the amount of energy peaks in the sound file within certain parameters. From the algorithm, I found that after stress, the chickens made less sound when compared to a non-stress situation. This was interesting, since it went against my hypothesis. This drop in calls observed could be attributed to some kind of freezing behavior due to stress. Animals that are in a stressful situation might choose to become more vigilant after a stress event and produce less sounds when compared when they are not stressed. The daily behavior schedule of the birds could also have an influence on their calls. Their feeding time or resting perhaps had an influence on the analysis. I also used neural network analysis to categorize the sounds produced by the birds in either a stress or a non-stress group. This artificial intelligence program was able to categorize this at an 86% accuracy. However, due to the design of the study, I am unable to say whether this categorizing happens because of the birds' differences in calls or because of the proximity to certain machinery to the microphone. Still, using these neural networks has shown promise in literature and is definitely crucial in especially the poultry industry. The data that I collected is very interesting, but we need to overcome a couple of hurdles before such techniques can be implemented in production systems. But developing and validating these methods is essential for the future of managing our livestock in an effective and constructive way.